Welcome. What I wanted to do today is show you how to evaluate functions. So a couple things where we're going to be talking about functions today. What we're going to talk about is function notation. So it's very important for us to understand, not only just what a function is, but how to use function notation and what exactly it actually is. So a function notation is very much like an equation, okay? We have one-sided equation equals the other-sided equations. Now remember, when we're talking about functions, that's a certain type of relationship where we have an input and we have an output. And whatever our input is going to give us a unique output value. So that is our function relationship. Now when looking for function notation, we have what we call f of x. And a lot of students get mixed up with this because they don't really understand, what does this f of x mean? Why can't we go back to using a y? Well, a y and an f of x are really exactly the same thing. They both represent the output value. But it's helpful for us to use function notation for exactly what I'm going to show you today. F of x is our output value. And what it really says is the value of the function f, named f. So f is really just the name of our function. You can see here I have my function as g of x, meaning the name of this function is g, just like you and I have names. Over here I use the function f as its name. So f represents the name. And what x is the value of the function at x. So the value of my function f at x is equal to my equation, x plus 1. Now my x is still going to be my input value or input variable, just like when we had x and y's. Remember, x was your independent value or your input, and your y is going to be your output and your dependent value, meaning it depends on the value of x. So the reason why function notation is so important is because let's say I do f of 2, and what that means is the value of my function f at 2 is different than the value of my function of f at x. So when the value of my function of f at x is x plus 1. But the value of my function f at 2, I'm now going to, instead of use x, I'm going to use 2, because that is going to be my new input value. So that is going to be 2 plus 1. And I can simplify that to actually equal 3. So what this says is the value of my function at 2 is actually equal to 3. So sometimes when we're going to be evaluating functions, we're going to get a value, and then other times, depending on what we evaluate our function for, we might get another expression. So what I'm going to do is I'm going to go through 2 examples. I'm going to show you how to evaluate them, and then I'm going to give you a couple examples, and I'll have you go ahead and evaluate them and see what you come up with. So on the first one, it says my value of my function f at x is equal to x squared plus 1. So what I want to do is I want to find the value of my function f at 2. So remember, your input values are right here. These are always your input values. So the only thing that I'm going to do now is, instead of using my input value of x, I'm going to plug in my input value of 2 to plug it in. So I have 2 squared plus 1. Now here I can simplify this. 2 squared is going to give me 4 plus 1, which ends up equaling 5. So therefore what I can write, and I'm kind of running out of space here, I can write f of 2 equals 5. Sorry, I'm just kind of running out of space. F of negative 4, now what I'll do is I'll plug in a negative 4 in for my input value, and then see if I can simplify it. Well, negative 4 times negative 4 is going to give me a positive 16 plus 1. Therefore, my final value of my function f at negative 4 is equal to 17. Now, let's say my input value is going to be t squared. That means I want to plug in t squared for my input. Well, again, you're just going to, wherever you see your variable, that is where you're going to plug in your t squared. So I'll have t squared plus 1. And remember, whenever we take an exponent to an exponent, you're going to multiply the exponent. So this gives me t to the 4th plus 1. Now I can't simplify this anymore, so the value of my function f at t squared is equal to t to the 4th plus 1. And the last one, I have a negative f of x plus 1, and this gets very confusing because it seems like, why do you have this negative sign outside here? Well, all that's really saying is you're going to take the negative of the function after you evaluate it for f of x. So all I'm really going to do is I'm still going to plug in my input value, which is x plus 1. So I have x plus 1 squared plus 1. But then what I need to make sure I do is I'm going to take the negative value of that. Well, before I do that, let's evaluate for what x plus 1 squared is, plus 1 is. Well, x plus 1 squared, I'm going to do this very quickly, is going to be x squared plus 2x plus 1 plus 1, which ends up equaling x squared plus 2x plus 2. Now it's said to take the negative value of that. So therefore, I'm just going to put these around parentheses. And now if I evaluate that, the negative f, so the opposite of my function evaluated at the point of f of x plus 1 equals negative x squared minus 2x minus 2 as I distribute my negative sign to all these terms. Okay, so now that was kind of the easy one. Here, the dread of everybody, piecewise functions. Piecewise functions, all they are is this problem twice. Okay? So a piecewise functions, all it is a list of 2 or more functions, but these special functions have constraints. Do you see here, no matter what my value was, I just plugged it into the function, right? It didn't matter. Whatever my function was, I plugged it in. Well, here, where do you plug your zeros in? Do you plug it into both of them? Do you plug it into one of them? And the way we determine that is what we call our constraints. So these constraints tell us which function to plug my value, my input value, into. So here it says g, find the value of my function g at negative 2. Well, we look at this, and what the constraints say is 2x plus 1, use that equation when your input values are less than or equal to 1. And then it says use the function x squared plus 2 when my values of x are greater than negative 1. So I look at negative 2 and I say, well, that is less than negative 1. So therefore, I am only going to plug it into my top equation. It does not go into this bottom equation because this is only for values that are greater than negative 1. So therefore, 2 times negative 2 is negative 4, plus 1 is negative 3. So I can say g of negative 2 equals negative 3. G of negative 1, so what is the value of my function at negative 1? Well, this says it has to be greater than negative 1. Negative 1 is not greater than negative 1, but, I don't know if you can see it, this is less than or equal to negative 1. So again, I'm going to use the same function. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. So the value of my function g at negative 1 is equal to negative 1. Last one, or last couple, g of 0. Let's just pick one. Let's do g of 2. G of 0, well, which number is greater than 0? 0 is not less than or equal to negative 1, but 0 is greater than negative 1. So therefore, I'll have 0 squared plus 2. So the value of my function g at 0 is equal to 2. And the last one, 2 is obviously greater than negative 1. It's not less than or equal to negative 1. So I'll just say 2 squared plus 2. So the value of my function g at 2 is equal to 2 squared is 4 plus 2 is 6. Okay, so those are a couple examples. Now what I want to do is I'm going to erase this, write up 2 more examples for you, and then I want you to complete the problems. I'll give you a couple tips, and then I'll show you the answers. That was quick.
Yeah, the kid never came to practice. I don't think he went to the west side.
Okay.
I just ran and came back.
Well, I'm going to finish up this video real quick, and then we'll be all set. Okay, so we got to hurry this through. So the next thing I want to do is, so here's your two functions. Go ahead and please try these two, and then come back to me and I'll show you the answers. That's my clock. Okay, cool. All right, so welcome back. Hope you did all right. To look at these next couple problems, remember what we're doing is we're just trying to evaluate for which function for our input value in the function f. So here I want to find the value of my function f at 0. So to do that, remember, when we're looking at a constraint with a piecewise function, this says evaluate this function for all values that are less than or equal to 0, evaluate 2x plus 1. And then it says use this function, 2x plus 2, for all my input values where my x is greater than 1. So I look at 0 and I say, well, 0 is obviously equal to 0. So I can only evaluate it for my top function. So I'll have 2 times 0 plus 1, where I'm going to plug in my input value into my x. Well, 2 times 0 is obviously 0, plus 1 will be 1. So therefore, the value of my function f at 0 is going to equal 1. For the next one, I want to find the value of my function f at 3. Well, we look at my input value and we say 3 is larger than 1, so I'm going to use my bottom function. So I have 2 times 3 plus 2. 2 times 3 is 6, plus 2 is going to equal 8. Therefore, the value of my function f at 3 is going to equal 8. So to summarize this, just remember, whenever you have your input value, no matter what it is, make sure you plug it in for all values in your function. Even if it's a piecewise function, make sure that you determine which function you're going to use. So finally, we have this last one. What I need to do is, again, we're going to take our input value and plug them into each function. So here I have f of negative 8. I'm going to plug into this function, which will be negative 8 plus 8. Well, negative 8 plus 8 is going to equal 0. Square root of 0 is 0. So the value of my function f at negative 8 is equal to 0. For this one, I say find the value of 1 for the function f. So therefore, my new input value is going to be 1. Rather than up here it was x, now it's going to be 1. Oh, I forgot. Sorry about that. It's plus 2, isn't it? So my value of my function actually is f of negative 8 equals 0 plus 2, which equals 2. Let's get a little crowded here.
1 plus 8, not 9.
Huh?
1 plus 8, not 9.
Yeah, I'm thinking ahead too, aren't I? So, going back here, so we have f of 1 equals 1 plus 8. Then outside the radical, plus 2. Well, 1 plus 8 is going to give me 9. Then plus 2. The square root of 9 is going to be 3 plus 2, which equals 5. So therefore, the value of my function 1, the value of my function f at 1 is equal to 5. And I kind of ran out of a little space, so let's do this over here. If I told you guys f of x minus 8 equals the square root of x plus 8 plus 2. So again, what I'm going to do is I'm going to plug in this value in for my x. So I have f of x minus 8 is equal to the square root. Instead of writing x, I'm now going to write x minus 8 plus 8 plus 2. Well, what I can do is inside my radical, I can cancel out my negative 8 and my 8 are going to give me 0, and I'll just be left with the square root of x plus 2. So unfortunately for here, we're going to have an expression. We're not going to have an exact value. But we can say the value of my function at x minus 8 for f is equal to the square root of x plus 2. Well, guys, that's how you evaluate functions. I hope this helped you out. Just remember, whatever your input value is, make sure you plug that into your function for your new input. That sucks. It took so long that my computer froze.
There we go.